Okay, so my name's Mike Hodge. I'm on the Human Connectome project in Dan Marcus's lab. I'm going to talk a little bit about that and the HCP's use of XNAT. So the goal of the HCP project is to kind of establish a baseline connectivity data set. And to do that, they're studying 1,200 healthy subjects, twins and their siblings, ages 22 to 35. We're collecting 4 3T MRI sessions per subject. We're also on some subjects, I think the goal was 200. I think we got 184 collecting 7T data. For that, they flew subjects up to the University of Minnesota where they have the 7T scanner. And they did that there. We've got MEG data on about 95 subjects and then also behavioral data. The end goal was a completely public data set available to whoever wants it. It's a huge data set, so you know, I don't know who all actually would go get it, but it's available. So there's multiple modalities, and this is just kind of the 3T stuff. We got structural T1 and T2, resting state, 2 pairs of scans, task, a pair of scans for 7 tasks, and diffusion. And what we share is the raw and then the pre-processed, and then we share some also kind of fully processed data. Usage statistics. Michael Heileman and our group put together a website that kind of pulls stuff down in terms of statistics. And so we've got over 8,400 user accounts, of whom 5,600 almost signed the HCP open access data use terms. 554 have gone and kind of filled out a form to get access to restricted data, which is kind of, we don't have any PHI in there, but it's, I guess, data deemed more sensitive. And especially since we're looking at twins and their families, it could get pretty easy for family members to identify each other, and probably not anyone else. So then we've also got some of the MGH Connectome data in there. So in terms of downloads, 6.5 petabytes of data have been downloaded via Aspera through the website. This just kind of shows where the access is coming from. A lot from the U.S. and a lot from China. Australia is big, and Europe. And then this shows because the data set is so large and it's rough to download, another mechanism for getting at the data is to just ship out a box of hard drives with the data on it. And I was surprised at the total on that. That's actually almost 3 petabytes of data that we just kind of shipped out by hard drive. So that's like half of even what was gotten at by the website. Surprised me. So
what would one package be for the, or do people never download that? Want the whole lot?
What would the whole lot be? What is, Michael? I bet you know the whole lot because you build the
terabytes.
Yeah.
So yeah, something like 8 terabyte hard drive. Oh, thanks.
So we have 2 XNAT instances to run to run the Connectome project. One is kind of internal, and the other is the public-facing site. So a little bit about the internal site. It's a lightly customized version of XNAT. It's not far from a standard XNAT. We're running 1.6.5 currently. We're not, one of the simplifying things of the Connectome project, it's a ton of data, but we're not using a bunch of scanners. And, really most of the data came from a 3T scanner here and the 7T scanner in UMin, and the data came via CTP. We run initial pipelines on IntraDB and do QC checks and data quality determinations. That kind of happens on this side. We run what we call sanity checks. It kind of looks for completeness and correctness of the data, especially Well, in the imaging data itself, but also files like ePrime task files and physio files and kind of other associated files to make sure that those are there. And the goal is to not send those to the public site. We want to make sure that the checks pass, that we've got kind of fully checked data before we send it to Connectome DB, where it's processed, because before we had the sanity checks and when things were missing, by the time the data got to all the places it went, it was kind of nightmarish to kind of push data everywhere it goes. So customizations, we have an InterDB. We've got uploaders for the scan-linked files for uploading MEG session data. We've got importers for our behavioral data and subject creation. And so our subjects are from the Missouri Twin Registry, and they do our screening. And they basically, when they screen them, they kind of send the subjects up so that our staff knew when to kind of start working with them. Behavioral data, we do our own importers because sometimes, you know, we've got one file that'll kind of populate multiple data types, and also because we do some scoring of the data. Our sanity checks, assessor and resources, data types, and some customized entry forms for stuff that's not uploaded, and then we've got some pipelines. The pipelines we run on the internal side or the face masking pipeline, which was written by Misha, who just talked. DICOM to NIFTY, QC and validation pipelines. This is just kind of a look at like the sanity checks assessor and just kind of some of the things it checks, and like sometimes when, you know, sometimes, for example, physio files can't be generated, and you know, that'll fail the check, so the user will kind of just check the session, and they'll be like, through this is kind of an interface that you can accept checks if you know, if we basically can't get at the data or something. But we want to verify that everything's passed before we go. This is the QC report, and Mohana's kind of worked on the QC pipelines for the HCP project. So then Connectome DB is a more heavily customized version of XNAT that's really geared towards getting people to the data they want to have. It's in a way stripped down. There's some parts of XNAT that aren't there, and then it's, you know, part of it are completely changed and overwritten. So most of the pipelines run on the Connectome DB side, except for the ones I told you. All of the processing pipelines run there, but I should put an asterisk there because they're not, the HCP pipelines aren't really run as XNAT pipelines. So the customizations for Connectome DB is we have a package-based distribution of data, which is we organize data into packages, many different packages like structural pre-processed, task pre-processed for each of the task data sets, all of the analysis. Each subject has, you know, kind of a bunch of packages, but the goal is to not, is so that people can just download what they want, you know, not, you can't download this whole database. So also we've got a JSON-based data dictionary, subject dashboard for filtering and access to project resources, subject groups, open versus restricted data access modes. We use Aspera to enable high-speed downloads, and subject keys is another customization. I'll speed up. Pipelines run on the supercomputer, and again, they kind of run on the file system, and kind of at the end, they build packages and push data up into XNAT. The organization of the data in the packages and on the Connectome in a box shipments are basically organized so that pipelines can run on them. Data is pushed into XNAT session resources, but we don't really access it from there. Screenshots, landing page of Connectome DB. This is just kind of where you hit. This is just kind of subject groups. Again, we do some kind of rational organization of subjects so you don't have to download any more data than you need. This is the download page. So this is kind of where you'll go and hit packages. Pick what you want, so you can make a bunch of selections over there and queue it for download. This is kind of Aspera, so there is client software that's an easy install that's involved, and when you do a download, Aspera is nice because it's a kind of a managed download, and you know, you can stop and restart it, and it's fast. You know, assuming you know your connection's fast. This is just an example of the filtering. You can basically filter by anything that's in the data dictionary. Tabs are also not based on our data types. They're actually kind of, they come from definitions in the data dictionary. So kind of most of the normal, what looks like a normal XNAT display is actually driven off the data dictionary rather than underlying data types. This is just kind of showing how to get to the restricted versus open access view if you have restricted access. And this is our project resources, just kind of how you get to other things that are kind of associated with the data. So where we're headed next is the Connectome Coordination Facility, which is basically to turn the Connectome DB into a central repository for all human connectome data. They're funding disease, state, and lifespan projects now, and many of these sites will run their own XNAT instances, and we're going to use Mohana is writing an XSync module that'll be used to push data to us from these sites, and she'll be talking about that in a talk later this week. This is just kind of the current CCF projects, and there's many more to come. And this is kind of the team. I mean, there's been a lot of people involved in the Connectome project. I'm like a tiny part of it. And, you know, including the XNAT team at the bottom, because I think almost every one of them have had their hand in it at some point. So URLs that are almost unreadable. But there is, you know, one thing is that Connectome DB and the humanconnectome.org website, but also there's a repository for all the pipeline code, which a lot of people might be interested in. Questions? I didn't. I covered it all. All right, thanks.